Basketball is about scoring. Coaching strategies, conditioning, defensive techniques, and a multitude of other factors are important, but a game ultimately comes down to being able to put the ball into the hoop. But what exactly are the principles behind the perfect shot? It all comes down to a science, and it's a science that assistant coach Katherine Bixby and graduate assistant Jess Farley know all about. In her career, Bixby finished with over 1,300 points, and Farley earned 4 consecutive all-conference selections in her tenure. These two know how to shoot a basketball. The main mechanical processes are depth perception, velocity, angle of release, and trajectory of the ball in flight. Each has to be exact in order to sink a shot, but there are a few tricks a player can use. For instance, a large arc would allow for the ball to avoid the rim and go through the net without interference. But many players can't attain the required force for this type of throw, and instead use a lower arc to skim the ball over the rim and into the net, enabling players to increase their range without increasing the force applied to the shot. The actual release of all shots depends on proper finger and wrist control of the ball. When a player overshoots the basket, she is usually applying too much force from the arms and too little from the wrist. By using proper hand techniques, the shot can be made using less force and will allow for better handling of the angle of release in the ball's trajectory. It's also important for the player to have the right stance. By having a lower, balanced stance, the player can easily gather upward momentum and better square her shoulders to the basket when taking a shot. Lastly comes timing. The ball needs to be released as the arms reach full extension. Premature release of the ball may make it easier for an opponent to block the shot. There are many variables that go into a basketball shot, as evidenced by this graph. A is the shooter's release height. B is the height of the hoop, which stays at 10 feet. V is the initial velocity of the shot, and the green line represents the trajectory of the shot. X is the shot distance, and Y is the maximum height of the shot. Newton's second law can also be applied to a basketball shot. The acceleration, A, of a body is parallel and directly proportional to the net force, F, acting on the body, is in the similar direction of the net force, and is inversely proportional to the mass, M, of the body. In an ideal situation, on average, if a player is 5'5" and shooting from the three-point line, their average shot angle will need to be around 50 degrees, and the ball will need to have a 1.2 second flight time in order to sink the bucket. So when all the elements are formed correctly, they combine to make a perfect shot.